Good morning, and yes, thank you for the invitation to talk about geophysics. And I reckon that I have perhaps the easiest introduction to a topic among the topics that are in today's program, because everyone knows about geophysics, or should we say geophys, courtesy of time team. We've all seen programs of time team at one time or another. We are dealing with geophysics with techniques that can sense beneath ground surface. They can do that non-destructively and rapidly. So in this first picture, the time team, taken from the time team website, arrived at the site, nice grassy area, and over on the left, a geophysical survey has been carried out, probably a resistivity survey, and the data is processed, and we can see that nice red-shaped feature or anomaly coming up. We can interpret that in terms of archaeology, building structures, and being time team have the luxury then of going straight into excavation, and on the right-hand side you can see the results, the confirmation that there is that building, that structure. Well, geophysical survey is a very large area of survey. It has simpler elements and it has much more technical elements to it. But I'd like to emphasize the way it should be thought of very much within the so-called survey package, in which we are getting a feel and understanding for the locality, the landscape that we're dealing with. And therefore, geophysical survey will be one component of this package. We'll be looking at aerial photos of the area we're interested in, probably or perhaps field walking has been done, topographic survey to look at small undulations, the humps and bumps at a potential site. Metal detectors might well have been over. We're moving to a stage where aerial photography is moving in the direction of incorporating LiDAR survey, which has the great opportunity of looking through dense vegetation to what lies on the ground. So I do emphasize the way geophysical surveys is not or should not be used just in isolation. The next point is that it does have very wide capability. It's generally done in rural areas, but as I'll show in a moment, it does have capability of working in urban areas over tarmac, stone, concrete, or whatever. And it does have an underwater component as well. So if we look here, just brought up a few images at random. Top left, an example of a large area geophysical survey, extensive survey, mapping out using the magnetometer the complete interior of the Roman town of Wroxeter. By contrast then, bottom left, a very small scale but very detailed, intensive survey of a single Roman building, looking at the way it is appearing, buried probably a metre down. Top right, an example of use of radar, which I'll mention in a moment. The point here, being able to survey within a building, within an urban area. An example of radar survey inside St Nicholas Church in Aberdeen. And then scan sonar survey on a large scale, bottom right, Scapa flow in Orkney, and a visualization of the German warship there. Let's just go for a moment to Orkney and just to pursue that point again, that combination of, potential combination of geophysical survey on land, over on the right, part of the very large geophysical survey carried out in this area of, well-known area of mainland Orkney, with Barnhouse stones of Stenes, now Ness of Brodgar, and that graphic there on the right that I will return to, and then over on the left, there we are, the very recent results of underwater geophysical survey. exploring the idea that over on the right we're interested in early prehistory on land, and the underwater survey making the point that the sea level in the Neolithic period and perhaps earlier is very different, and therefore the archaeology is offshore, and the geophysical survey should be looking at what is now in the or under the lakes. Now let's come to the instrumentation, and I highlight straight away the so-called workhorses of geophysical survey, resistivity, magnetometry in particular. So on the right, resistivity, measuring electrical resistance, and they were walking with a probe, and we're getting readings of electrical resistance over our survey area, and then we can go straight to this plot here, and we know that there are fairly straightforward electrical signatures over particular features, an increase in resistivity there, and so on. More common, arguably, is the magnetometer, one sort of magnetometer top right, and again, it gives a particular magnetic signature over certain features. And then in the front, ground-penetrating radar. We're very concerned with scale and speed these days, and so the days of where we carry the instrument over the survey area is certainly not gone, but people are thinking more and more about speeding up survey to carry out large-scale surveys, and so we attach the instruments to carts, and the luxury now is where you have this kind of system where you don't have to do anything, you just sit in the van and drive across the field. The message here is that we are able to move from very small-scale surveys to very large areas. Awareness that there are many other techniques, like susceptibility. I'm going to go, I won't go through those in any detail, but just awareness that according to particular features and structures, we need to be able to adapt and draw in other techniques. And I particularly emphasize the role of chemical analysis. The process, we need to think about the terrain, no metal on the surface. We've got to think about whether we do a fairly coarse survey, the kind of resolution we want from our survey. It is a sad fact that so many surveys we do, this is thinking about terrain, are going to have metal in them, the metal fence, the pipeline. It is amazing how often our surveys are affected by modern intrusions. Time up. I put here, this is the harder part, and perhaps this is a point that I'll want to discuss in the surgery this afternoon. So I'm forced to end there. Thank you.